In today's note, we are going to be going over the Tangram activity. So if you followed along on Desmos, you would have seen all the videos and the explanation as well. But I'm just going to do an explanation again, just based on the actual handout that you would have gotten. But again, you can follow along either one in order to do this. So we're looking at this tangram, and the tangram is this square over here made up of different shapes. If the total area is pictured as 1, what is the area of each of the smaller pieces? So this whole area is equal to 1, or 1 unit, whatever it happens to be. So we want to know what is the area of each of the smaller pieces. Right? If you go to this website, the mathagon.org/tangram, you can bring up a actual manipulative, basically a digital version. I'm going to be playing around with one here. So basically you can just click on the squares or the shapes, you can rotate them, you can overlap them to basically get an idea of, or to manipulate them and hopefully help solve the question a little bit better. So looking at this, if I'm looking at this shape, I'm going to start with the pink triangle or the large triangle. So the large triangle, if I look at it, it's the same as the blue square or blue triangles. These two are the same, and I can see that they make up roughly they make up exactly half of this square. So if together they're half, then individually they have to be a quarter. So the pink triangle or the pink shape and the blue shape are both a quarter each. Next, what I'm going to do is I'm going to take a look at this purple shape. And this purple shape, if I look at it and compare it, I can see that when I overlap the two, this purple shape is half of the pink shape. So the purple or the medium triangle is half of the large one. So if I look at, and a large one is a quarter, well then half of a quarter is an eighth. So the purple one is 1/8. Next, I'm going to look at the green piece. So if I were to cut this green piece in half, or I'm going to take it out, if I take a look at this green piece, I move it around, I can see that it's a part of the blue shape. And if I were to look at the blue shape, I could see that it would roughly make up half of or the green shape would make up half of my blue triangle. And I can see that it would be, overlapped it. But I can see that there'd be one triangle here, one triangle here, and it looks like there's roughly 2 triangles here. If I look to overlap it, I can see that it does make those shapes. So this green square is half of the blue piece, and it'd be the same for the pink piece. So it'd be the same as the purple piece. And if I look at the purple piece and overlap it, I should see that, okay, if I match it up correctly, should see that again there's going to be roughly half, or this purple shape is going to be the same as the green square. So the green square is also 1/8. Next, I'm going to look at the orange piece. And this orange piece, if I look at it, or this orange one, yeah, it is half of the square. So if it's half of the square, then a half of an eighth is, or I guess it's the red or the redder shape. So the half of an eighth is 1/16. So now I know that shape. The green teal shape, I can see that it's the exact same by overlapping them. Even move them into different spots and they'd fit. So I know that the teal triangle is 1/16 as well. And then next is this orange parallelogram. So if I pull that out and look at it, I can see that if I take my small triangles and combine them, they added together make up that orange, or this orangey parallelogram. So what that means then is that these two added together make the parallelogram. So 1/8 plus 1/8 will give me, or sorry, 1/16 plus 1/16 will give me 1/8. So those are my areas of each of the small shapes. What we're going to do now is, again, go through a few more questions and just, again, looking at this idea of fractions and putting them together. So I'm going to look at putting pieces together. So I want to know in the first one, what is the area as a fraction of the small triangle, so this one, plus the parallelogram together? Well, putting these two together, as we can see over here in the shape, if I put them together, I'm going to roughly draw it out. Be something similar to that. Right? We know that the parallelogram is 1/8, and we know the bottom one is 1/16. If I add those two together, right, I'm going to be adding fractions. So 1/8 plus 1/16, I want to figure out what does that equal. And if we remember about adding fractions, in order to add fractions, we need a common denominator. So we need a common bottom number. So in this case, I need to get it to 16. 16 is going to be the common denominator. And in order to do that, I'm going to multiply both the bottom and the top of my one fraction by 2. And from here, I get 2/16 plus 1/16 is what it becomes. And then this I can simplify, because when I add fractions, if they have the common denominator, I just add the top numbers. So 3/16 is the total area for these two triangles, or sorry, for these two shapes. The next one that we're going to look at is, what is the area as a fraction of the two small triangles? So we're going to use these two small triangles over here plus one large triangle. So again, we could play around with the shapes, whatnot. I'm just going to draw out roughly what they are. So we have our large triangle and our small triangle. So in our large triangle, this was 1/4. Then we have 1/16 and 1/16. Right? So if I combine these together, I'm going to add these up. So 1/4 plus 1/16 plus 1/16. Right? I can't add these up because they don't have a common denominator. Two of them do. So if I wanted to simplify this, I could. 1/4 plus 2/16, right? Just add the two ones. The denominator does not change. I don't have a common denominator yet. So what I need to do is I need to multiply my first fraction by a number so that I get a common denominator. In this case, I'm going to multiply it by 4. So I'm going to multiply both parts by 4. And I'm going to get 4/16 plus 2/16. So 1/4 is the same as 4/16. And when I add these two together, I get 6/16. I can reduce this if I want. So 6/16 can be reduced to 3/8. So again, I'm just adding fractions. For number 3, I want to know, what is the area as a fraction of the large triangle minus the small triangle? So if I take a small triangle out, how much is left? Right? So I have my large triangle. We can see it over in our little window to the right, I have this shape here, and I'm going to cut this much out. Right? So when I redraw this, what it will look like will be something like that. And I'm missing this piece here. So basically I have a giant shape that is 1/4, and I'm subtracting 1/16. So 1/4 minus 1/16. Again, I need to get a common denominator when I'm subtracting. So we already know how to change the first one. We're going to multiply both parts by 4. So we get 4/16 minus 1/16, which equals 3/16. Because when we're subtracting fractions, we just subtract the top numbers and leave the bottom the same. And we can kind of see that if I look at this visual, we can see that this makes up, there are 4 triangles, or 4 small triangles, that make up a large one. So if I take away this one down here, I'm left with 3 triangles. Or basically 3/16, because each triangle is 1/16. So again, you can play around with the triangles and figure that out as well. Looking at example number 4, how many small triangles would fit into one large triangle? And we've already kind of done this, right? We just showed this example, right? Because we took our large triangle. So we took our large triangle out, and if I put this blue one here, I can see that it does divide it up into 4 equal triangles. So I know that it takes 4 small triangles to fit into one large triangle. So I can do that, I can show that visually, but how do I show that mathematically? Well, to do that mathematically, if I have the large triangle, 1/4, and I want to break it up into small triangles, I'm going to divide. And so the way we do that is when we divide fractions, we flip the second one and we multiply. So if I want to flip my second one, so I'm going to flip this. So I get 1/4 multiplied now by 16/1, which becomes 16/4. And if I solve this fraction, I get 4. So this is my mathematical calculation to show that when I divide the large triangle by the small triangle, I get 4, which I can see works because I have 1, 2, 3, 4 triangles, or 4 small triangles in that large one. So therefore 4 small triangles fit into one large. So the next ones are going to be ones that you can do on your own, right? Which of these pieces would you use to create an area of 3/8? Which pieces would you use to create an area of 3/4? And which pieces would you use to create an area of 3/32s? Or 3/32. There's more than one answer for these, but again, use the squares or use the shapes if you have to, play around with them. Use the idea of fractions and try to come up with some interesting answers. But again, the main thing from this is just kind of reviewing the options that we're dealing with fractions, right? Division, addition, subtraction, multiplication if you may need that. But again, just an interesting way to review that concept.